Yeah, so let's continue regarding the page layout. And so yesterday we have seen how the page layout looks like. So it has, so for example, if you create any table space, so we have number of physical files, each file is 1 GB. And whenever 1 GB file is full, then it generates one more physical file and so on based on your data, right? So each physical file have number of pages and each page looks like this. Each page have page header, line pointer, row data with row header, and free slots and special space. Okay. And the free slots also have the upper and lower bound values where the free space exists. And page header has 24 bytes. It has some sort of metadata regarding related to this page. Okay. So like check some value, and it also have the, so we have seen yesterday. Okay. So lower and upper value, special, LSN number, and so on. So these things it has in the page header. Okay. And line pointer is actually pointing to your row data, and it will represent as an offset. And if you take a single row, if you want to fit it rows in a page, if you take a single row looks like this. Okay, it has the row header with 24 bytes and followed by the columns. So these columns based on your data type which you have defined. So based on that, it will allocate the storage. Okay, and while allocating storage, basically, it will allocate a fixed size basically. Okay, and with this fixed size, few times it will also waste your space. Okay, that we will see how it will waste the space, and if you reorder the columns, how we can save the space. Okay, in these scenarios we will see in coming slides. So for now, this is the how the page layout looks like, and the special space is for only index kind of metadata information will be present in the special space. Okay, and even we have row header. Okay, row header have some system columns like CTID, XMIN, and XMAX, and followed by it also have the Infomax values, and it has the actual row data length and exactly the line pointer where it is pointing currently. Okay, with the offset values. So this all information it exists in the row header. Okay, and if we want to see this internal page, for example, page header or row header, how it looks like. So by default, we don't have any kinds of system catalog views or any kind of system functions. So we have to create extensions. With the help of extensions, we can able to see the data with the help of some functions. Like if you want to see any page, okay, we have to install PG free space map and PG inspect or page inspect. Okay, with the help of these two extensions, we can able to read the page header with row page with get row page function. Okay, we can able to read this, and similar way we can able to read our actual row header information with the heap page items table or function, whatever we call. Okay, so if you install those extensions, then only we can able to read this kind of data. By default we cannot. So what is an extension and what is the use of extension, how to install those extensions, we will discuss. Okay, basically extension is just an additional packages or additional software which we are going to attach to our Postgres binaries. So there is a module called, there is a package called PostgreSQL contrib. Okay, in initially when we are installing the cluster, we discuss about this contrib module. So when you install that package contrib module, we will get some set of extensions, inbuilt extensions. So we can install with our in our database basically. So that also we will see practically how we can set up the extensions with the help of contrib modules and how we can create the extensions. Okay, so by default we cannot read the data without the help of the extensions. Okay. So this is just a overview of the page layout, how it looks like. And so we discuss about these flags, okay, various flags which it stores in the page header. So with the help of this get raw page, so this function will be available whenever you create extension. Without extension, you cannot able to get this table followed by this function. Okay, page header get raw page is one of the internal tables functions which will be created as part of your extensions. Without extension, we don't get this kind of functions to read your page header. Okay, so now what I'm doing for IMDb is a table. I'm just reading how the page. So page header looks like for 0 page. Okay, so pages will start with 0 and so on. So for 0 page, how the page header looks like, I have just selected the query, and this is the values which I get from this page header, which we already discussed yesterday. So LSN is it's a kind of sequence number. Whenever you do any commit or any operations, automatically Postgres will allocate the LSN number. Okay, this will be in hexadecimal value, and this is how the current LSN number looks like. Okay, so here basically, if you think about Oracle, okay, we have a SCN number. Similar kind of representation will be in the two formats. One is LSN and the other is transaction IDs. Okay, so LSN is one of the format which it will allocate, which it will update in the page header. And we have checksum. So checksum, when we enable, it will mark as 1, otherwise it remains 0 by default. And flags, okay, we have some special flags in Postgres, 0, 1, 2, okay. So regarding these special flags, if you want to understand, you need to understand about the transaction ID. So what is the transaction ID freeze, okay, so that you will get better understand in vacuuming classes or MVCC classes. So for now, we have some special flags, 0, 1, 2, okay. So it depends on your case, it will update. By default, it will be 0. Okay, whenever you reaches the transaction IDs, it will update the special flag here. Okay, this is about PG flag, and we have lower and upper, which is like the offset, which represent the start of your free space and end of your free space in your page. Okay, and we have special, which is for index access method. Okay, and we have version is 4. After 8.3 it remains same, it not change. And whenever you have any index created, okay, so this pronex ID will make sure it will go and fetch that particular records directly instead of going and scanning all the pages. Okay? So this is how the page header looks like, and followed by row header. Okay, so we also have a row header, looks like this. So basically we know tuple is nothing but a row. Okay, row is basically fundamental unit in the Postgres, and each row have a header followed by data. Data will be continuous array of your cells or continuous array of your storage bits which it allocates in the memory and disk, okay, based on your data type which you define. And header is like 24 bytes followed by your original data, okay. And this is how the row header looks like. We have line pointer offset. So line pointer starts with 1, and currently it is pointing to 81020 location where your actual record is storing. And we have length. Okay, so this is the actual length of your data. So how it calculates the length, it will add your 24 bytes of your 24 bytes of your header plus whatever data types which you define. For example, int, if you define int, okay, it is 4 bytes. If it is a small int, it is a 2 byte. Okay, and if it is big int, it is 8 bytes. So based on that, it will calculate. So 24 plus 4 plus 4 plus 2 plus 8 and so on. So like this, it will calculate, and your total length looks like this, 72. Okay. And you have a xmin and xmax, which is the system columns. Whenever you do any insert statement, your xmin value will update and xmax remains 0. When you do an update and deletes, xmax will be allocated as a transaction ID and xmin will remain 0. Okay. And these are the system columns, which you will understand better in MVCC and vacuuming. And we have CTID. Okay, CTID is the one which is going to point out to your row. Okay, like it's a row ID. So in the page 0, it is currently pointing to offset of 1. Okay, and so on. So we have seen in the screenshot here how it represents with the CTID. This is the first record. For the first row, it is pointing in the 0 page and the first line pointer. And in the second, it is in the 0 page, it is pointing to second line pointer, and so on. Once the first page is filled, then it will start with 1. Okay. So here it is still all the data which is storing in the first page. Okay. Once the first page is filled, you could see here, it will also represent 1, 2, and so on. Okay. And this Infomax is also one of the important. Basically, it is a 16-bit value. Okay. Here usually it gives like 4, I think some bytes. Okay. 2 bytes. So if you convert this into 16-bit, it will give zeros and ones. So based on the type of data which you are storing in the table, based on that, this Infomax will be updated. For example, if you have any null values, at the last of your bit, it will have 1. Okay, if you don't have, it will represent as 0. Some sort of information it will write in the Infomax. Okay, and this is your actual data length. This is 72. Okay, this 72 length of your data will be finally represented like this. Okay, in hexadecimal bits. Okay, like this. So we will see practically so that you will understand better how we can read the row header, how we can read the page header, and how we can calculate this length based on your data types. We will discuss. Okay. And let's discuss about the heap tables. Basically, your row is fitting in the page, right? So those we call it as those tables we call it as a heap tables, right? Because the access method for table is a heap. So basically, whenever your data is storing in the heap table, so basically it is in unorganized way. So wherever you have free space, okay, where there it will go and fit your new data, right? It will not fit in your like not in the serial format, right? So randomly it will fit your data, how you are inserting based on your free space available in the page, right? So if you want to arrange in the, in particular order, you have to use select statements like order by class and so on, right? So you have some functions, you can just use those functions, order by class, to retrieve your data in particular ascending order or descending order based on your order by class and descending function, right? So basically it will be in unorganized way. At this point we have to keep in mind in your page whenever you are trying to fit, okay? Based on your data, how you are inserting, it will be inserted in unorganized way. So if you want to filter the data based on your requirement, you have to use the select statement and you have to filter with order by class and so on. Okay. And this row order will be changed. We can change with the, so we have a concept called clustering. Okay. So when you create an index and when you do a clustering on this particular table, the data at the storage layer will be also in ascending order. So this we will see in performance class, how we can do that. But for now, we have to just remember that in heap table, the data will be in unorganized way, not in organized way. So whenever you do any reorganization like vacuuming, then only the row order will change. Until that, how you are inserting the data, it will just store, randomly wherever it has the free space available in the page, okay, in unorganized way. So if you want to organize, you have to use select statement, order by class, or you have to do some maintenance activity like reorg kind of activities with the vacuuming, or we also have clustering, the concepts which we discuss in further modules. Okay. So for now, we just need to remember that in the heap tables, the data will be stored in unorganized way. And because of this unorganized way and the data which we are trying to fit, okay, with the data type, we also see some extra waste space, okay. So that we'll discuss in the coming slides in the padding, okay. So what is the padding and how the extra storage will be allocated and how the column order is important, okay. So that we'll see in the coming slides. So in these slides, we need to just keep in mind that our data will be stored in an organized way in the pages. Okay, this is how the page looks like. which we have seen in the diagrammatic. Same thing we are representing here. So page header is 24 bytes and we have item pointer of 4 bytes. Okay. And we have free space with the actual row header with the row data. This is the tuples. Tuples is our actual data. Along with this, it also have the row header as well. Okay. And followed by special space. This page is same for table and index. Both the data. Okay. It has the same representation of your page. Okay. So as discussed, whenever the page has index data, okay, it has a special entry in this special space. Okay, it will write an extra information in this special space, like where it has to point out to your data for your actual table. Okay, it will point out. So some kind of metadata will write in the special space. Okay, if that page contains of index data. Okay, if it has only table data, it won't write to any information in the special space. Okay, special space is this. Okay, this is the special space. If you have any index data, it will write here for that particular page. So these points we already discussed. Basically, item points to your tuple, okay, which means to your actual row, the item pointer will point out. Okay, and it also have some system columns like xmin and xmax to based on your data, how you are inserting and updating, these values will be allocated. So this is the same things which we already discussed. Okay. So now this is very important. So we need to understand about the padding logic basically. So what is the padding and how the padding will be allocated if you create any table with specific columns, okay, based on your data types. So basically padding is nothing but an extra space, an extra waste space will be allocated before of your data types. For example, I have a column C1, okay, of type integer, and I have a column C2 of type big int. Okay, so between two data types, since it is a fixed length, okay, so it will allocate an extra space because of your variable. So because of your fixed data types, okay, so it will have some extra waste space. So that we call it as a padding. So padding is something called an extra waste space based on your data type, how you are defined. So you have to design your table in such a way that it should not waste your space, right? You have to use the variable data types instead of fixed data types. So this matters a lot in terms of performance and your storage wastage. Okay, and so this in this diagram, so this is my row header, and this is the column data with the column, for example, column C1, C2, and so on. Okay, so C1 column, for example, I have allocated an integer. Integer is a 4 byte, and I have allocated a string. String is like text. Okay, it is 32 bytes. And in the C language, we know always for strings it will be an extra for trailing character, right? So this is known issues. Okay, so which means 33 bytes. And if you declare float, it is 8 bytes. Okay, how the length of your row will be calculated is 24 bytes of your row header plus 4 bytes of your integer. Even though if you insert 2 bits into this, the space will be wasted. Okay, these are all the fixed length, right, of your data types. And string plus 33 plus 8. So when you add this all values, then you will get the total length of your row. So in this, so here if you see, this is your actual length. Okay, this value how you will calculate based on your data types plus your row header 24 bytes. This is how you need to calculate. Okay, so when you are defining this particular column data type, we have to define very carefully. It's always good that you allocate the column order. So order matters a lot because, for example, if you allocate based on from higher data type to lower data type, okay, so it will save a lot of space. instead of wasting your space. So this we'll see practically to understand better two scenarios. If I create a table with some particular columns with the data types, and we calculate the length of the row, and later we will also create the other table by arranging the column order, and we'll see how the length looks like and how the performance looks like. Okay. So here we need to understand padding is something called extra wasting space for your data types which we are going to define. Okay. So for example, if you define, if you take example, what is the difference between varchar and varchar2? Okay, so varchar2, if you define, it will allocate the fixed, right? So varchar is, variable, right? So if you define varchar, it is like fixed, right? So you understand, right, the concept like between difference between varchar and varchar2. Okay, so it won't waste much space in varchar2 because it will allocate whatever the string which you are trying to insert. So based on that one, it will allocate the storage in the memory as well as your disk. Okay, so it will not waste your padding. I mean the extra space. Okay, so this to understand better, we have to discuss in the practical so that you will understand better.
Yeah, Malati.
Sorry, by mistake, I was unmuted.
Yeah, no question.
Yeah. Any questions so far? Yeah. So before we discuss about the toast, we have to discuss, let's go and do a practical. Okay. So my Postgres cluster is up and running. Okay. Now the first thing is we have to create the extensions. So okay, if I want to check whether my contrib module is installed and what are the available extensions I have in my Postgres cluster, I can just run select from pg available extensions. Okay, so this is the catalog view where you can check the available extensions. So for now, I don't have any extensions available for this cluster because I don't have contrib module installed as a part of my Postgres cluster. Okay, so let's go and install the contrib module. So I'm install Postgres SQL 15 contrib. Okay, so this is the package. And since my cluster is running in the 15 version, I'm going to install this. Even this particular package is available in PostgreSQL.org if you open. So you have, along with your server, PostgreSQL server, you also, it's always good to install contrib module at the time of installation itself. So when you install this contrib module, you will get some set of extensions so that you can install that extensions and you can play around with that extensions. Okay, for example, PG free space, PE page inspect. So these kind of extensions we can able to install. Once along with this contrib module only, we get that extensions. So it's always good practice that you can install this package along with your Postgres installation so that we don't need to be installed later point of time. In real time, basically this will be installed as a part of your installation. Okay. So when you install this contrib module, okay, so we have a, okay, let me switch to Postgres.
So when we install this extension, is there any downtime is required or it's online activity?
No, it's an online. If you go at this location, we have a folder called share, right? So inside this share, okay, we have a folder called contrib. Okay, so in this contrib only, it will install all your all your packages. Okay, here we have extensions. Okay, these are all called extension SQL files. Okay, for example, if I install an extension called page inspect, this is the files which it is going to read and it will create. So in these files, it has the predefined tables, predefined functions, predefined packages. Okay, so these SQL files it has. This will comes along with your contrib module. When you install this contrib module, you will get this inside the share folder. Okay, it will create all the SQL files, this kind of SQL files. And if you want to use PG buffer extension, buffer cache, you can just install this. And we are going to install to see your page layout, PG free space map and page inspect. These are the two important extensions which we need to be installed. Okay, so this will be present in your share folder. Okay, in the binary location. Okay, so now what I will do, I will just connect to my Postgres and let me execute the same query after installing my contrib modules. Now you could see we have so many modules, right? So if you see DB link is one of the extension, okay? Admin pack is one of the extension. And we have FDW, which is for foreign data wrappers, okay? And we have page wall inspect also. If you want to inspect your wall files, you can just create this extension. PG stat statement. This is for performance kind of stats it will gather. For now, we are installing PG free space followed by page inspect. Okay?
Yeah, we will discuss more about these extensions in Oracle to PostgreSQL migration classes. There you will get better understanding, and there we will use more extensions.
Yeah. So now what I'm trying to do is, and this extension is specific to your database. Okay, not like entire cluster. For example, currently I'm in Postgres database. If you create this extension in this database, it is applicable for this database. And if you want to use this extensions from other database, you have to create there as well, because when you create this extension, it will create some set of tables and functions, right? That will be created in that database as well. Okay, we cannot use this database extension in some other database. This is specific to database. That point also we need to keep in mind. Okay, so now what I'm trying to do is, okay, let me check. Okay, I have a database called TargetDB something. Okay, and here I'm going to create an extensions. How can I check what are the extensions currently which is already created? So you can just use /tx. Okay, so for now, this is the default extension whenever you create your Postgres class, which is a PGP SQL. Okay, this is the default extension which will be installed as part of your cluster installation. And apart from this, I'm just trying to create extension PG free space map. Okay. Now you could see it is installed. Okay, this is the version it is installed and in which schema it has installed and this description. So what this is mainly useful to examine your free space map. Okay, so if you want to see the free space of your page with the help of this PG free space map extension, you can able to see how much free space I have in the page. Okay, page 0, page 1, and so on. So based on the page, we can able to see. And that also we will see. And along with this, we also create a extension called page inspect. Okay. So for now, these two extensions is much needed to read your page header, page data, and row header. Okay. So these two extensions is, without these two extensions, we cannot able to read anything. Okay. Now, okay, let's go and create a few tables and we'll see how the page header looks like for the table and how we can see the row header and page header as well. Okay. So before that, we have a utility called OID to name. Okay. So this OID to name will list your OID of your table space along with the database name for this database, which is the table space which it's allocated. So for now, you see all is PG default. If you create any customized table space, it will also show here. So OID to name is one of the utility to check your table space information as well. Even you can just do -help. It has a like one bunch of option. If you want to see for indexes, you can just use -i, and if you want to see for only system objects, you can just use -s, and so on. Okay. So this utility also you can just keep in mind to see your table space information. For example, OID to name. I want to see for system objects for target database, target DB. Okay, it will display all your system as well as toast. Okay, toast tables. What is toast tables? We'll discuss in the next coming slides. Okay, so for this department and what is a file node? Okay, and employee. So it will display all your file nodes in your target DB database. Okay, like this, you can just play around with the OID to name. Okay, and now I'm trying to connect to my database called target DB. Okay, and here I'm trying to create a table called, let's say, for example, heap. Okay, and it has one column 1 of data type int. Okay, and if you see your table, so I have only one column of integer type. Okay, integer type is by default 4 bytes. Okay, now I'm trying to insert few records into this table by using generate series function. So there is a function called generate series. With the help of that function, I will try to insert some 1000 records or maybe some records into this table. So insert into heap. I'm trying to generate some series of values with some I variable, generate series. Maybe I will try to start to insert from 1 to 1000 with increment by 1, or maybe 10,000 with increment by 1. Okay, so by using this function, I have inserted some 10,000 records into this table, heap table, right? So I'm just trying to fetch the count. So this is the count, and if you see, select start from heap limit 20. Okay, so this is the first 20 records I'm trying to fetch, and it has some 10,000 series of values from 1 to 10,000. Okay, and limit is just like your row num. So row num less than 10 you use in Oracle, right? Similarly, you use limit in Postgres. Okay, we can just fetch the first 20 records of my table. Okay, so this is my first 20 records, and so on. It has like up to 10,000 because I have inserted 10,000 records. Okay, now I want to see how the page 0 looks like for this table. So let's see how we can do that. So I have, okay. So I have already created my extensions in this database so that I can able to read that particular page. We have page underscore header and function is raw get okay, this is the function which I'm using, okay, for table heap, because my table name is heap. Okay, I'm going to read page 0 for this table, how it looks like. Okay, if you see the page 0 for this heap table, okay, this is how the page header looks like. So it has the LSN number, it has a checksum, it has the flags, lower and upper value, special, page size, and it has a version and prune excited. Okay, so this is the information of your page header. If you want to see in proper order, you can just see like this. Okay, so LSN number, checksum, flags. This is the switch we discussed. This is how the page header looks like for 0 page. In similar way, you can just check if this data is exist. Okay, this data is already inserted in the page 1 as well. Okay, so for page 1, this is how the page header looks like. So like this, you can just fetch this page header with the help of these 2 extensions. Okay, and we also have a system column called CTID. So let's see how it looks like. CTID, comma star. Okay, in the heap table, since this table is very big, I'm just trying to limit to some 10 rows. Okay, so this is how your CTID looks like. So basically CTID is some system column which is invisible. Okay, if you explicitly mention the system column, then your data will be displayed. Otherwise, if you just use select star from heap, it will only display your original column data. And this is something called system hidden column. And you could see here page 0. So this represents a page 0, and this represents the line pointer 1, 2, 3, and so on, based on your how many rows you have. This is how your CTID looks like. Okay, along with the CTID, we also have some system columns like xmin and xmax. Okay, that you will understand better in MVCC class, how it allocates the xmin and xmax values. Okay, now I want to check the free space of this table. How I can check? I can just check from pg underscore free space function, and this is my heap table. If you see, since it has so many records, okay, block 0, it does not have any free space available. And in the block 1, it does not have any free space available, and so on. So if you see 44th block, I have this much free space available. Okay, this is how you can check the free space of your this particular table. Okay, based on the page free space function, this will just give the block number as well as your free space, how much available. So up to 43 block number, you don't have any free space. From block 44, you have free space available. Okay, and let's see about the row header, how we can read the row header of this particular table. So table is heap. Okay, so this heap table we already seen in the page header how it looks like, page 0 and page 1, and we also see how the free space is available, and we have seen the CTID how it looks like, right? And now let's go and read the row header how it looks like for this particular table. This row header basically will be read with the help of heap page items. So there is a table called heap page item. With the help of heap page items, we can just read our row header page information. So let me run this query. Okay, so here heap page item, and I'm getting raw page for heap, and this is the 0 page. Okay, I'm just trying to limit with the 10, and I'm trying to fetch LP of LP length. These are all your row header information, right? Infomax. So this Infomax I converted to 16-bit. Okay, Infomax 2. So we'll see how it looks like. It looks like this. This is actual length of your row, and this is the offset, which means the line pointer is currently pointing to this area. Okay, and we have offset, and this is the CTID, and this is how the Infomax looks like. Okay, so this Infomax, since I don't have any null values in this column, if you see, all is zeros, right? And if I try to insert any null value, okay, then it will represent in different format. Okay. So basically this LP is a line pointer or item pointer. We call it as, it is indicating from 1. Okay. This LP offset is position of your item pointer, and currently it is pointing to this 8160 for this particular record. Okay. And this is your actual row data, total row length of your data, and this is your Infomax information, which I have converted into 16 bits. Okay. And we have offset, right? This is like row header. Okay, we can say row header is 24 bytes. So each record have 24 bytes. Okay. And even still we can fetch more information. So what I will do is, instead of mentioning the specific columns, I will just do select start from. Okay, so select start from. Let me arrange in the proper order. Maybe instead of limit 10, I will just go with 1 to understand better. Okay, so this all is my row header information. Okay, so line pointer, offset flag, length, xmin and xmax. So xmin is the current transaction ID. Since it's a inserts, it allocated the xmin. If you do an update and delete, it will update the xmax. Okay, this is the CTID of my first record. Because I have just given limit 1, it gives only information of my first record. Okay, and by default, this Infomax value will be, not in the 16-bit. We have to convert explicitly in the 16-bit if you want. This is actually your data. Okay, this data will store like this. So this is how you can read your row header. Okay, how it looks like for the first row. This we are trying to read from only for the first row because I have given the limit 1. In similar way, you can read for all the rows. For all the rows. So each row have its own header followed by this information. Now what I will do, I will just try to truncate this table. Okay. After truncate, I will try to insert. So currently I don't have any records from this table, right? Okay, I don't have any records. Now what I will try to do is, I will try to insert a null value into it. Okay, so we'll see how this looks like. I have inserted a null value into this table. Now let me go and read this particular page, how it looks like. Maybe I'll convert into 16-bit so that it's easy to understand. If you see the Infomax value for the first record, it is appended as 1 here because of my null value. If you go and see here, so the last value is 0 because it doesn't have any null values. This is how it represents based on your data, how you are inserting the type of data. Okay, this Infomax value will be updated. Okay, from this row header. Okay, so any questions here up to here? So for what we did, we have just reading the header information of your page. So you may have doubt like why we need to read. So this we don't need actually. So just to understand internals of your page. So we need how it looks like. So you may have some interest, right? So for this, you can just read this, how it looks like. And even in Postgres, okay, few of the things even you will understand better in Oracle side also if you understand Postgres, because in Oracle, this kind of information they will not reveal. You cannot go and see inside how it looks like based on your data, how it stores. So, but since Postgres is an open source, okay, you can go and play around it with the headers and how it looks like internally. So it's interesting. Okay. Yeah. Now,
One question with reference to this info mask. If the table has multiple, now the example table that you have is just one column table, right?
yes.
If it has multiple columns and does this last bit showing a 0 or 1 represent a null for every column, or is that
Yeah, it will show for every column. So basically now we are reading row, right? So for row, it is represent in the row level basically. So for that particular column, so it also represent for the other columns as well. Similarly, like how it is representing. So we are just reading for particular row so that it is just giving in like this. Okay, if you have multiple columns and multiple records, so it will also give that information. Sorry.
oh, okay.
Yeah. So now, but to understand better about the padding, okay, what I'm trying to do is I'm trying to create two tables. Okay. So I created two tables. One is called DVD rental pad and DVD rental pack D. Okay, these are the two tables. And these two tables having these columns. Column C1 I have defined as int 2. Column C2 int 8. Column C3 int 4. Column C4, C5 and C6 and so on. Same table with the other table, same column names, same data type, but I have just changed the order of my column. Okay, to understand better, /D. So what is the difference between two tables? In this table, I have 6 columns. In this table also I have 6 columns. And the C1, for C1 column, I have small int. For C1, I have small int. For C2, I have big int. And here for C2 also I have big int. Same column, same data types, only the order is different. Okay. You see C1, C2 and so on, C6. Here I have just arranged from smaller to higher. It has some mixed, I mean, it not have like, proper order. So while you do any deployments in the database, if any developers gives you, okay, to deploy any tables, so we should not go and blindly to create the table. We also need to think about your order of your column. Okay, how the order of your column matters. Okay, we will see now one example. Okay, so now I have created two tables, C1, C2 and C6 with the same data types in the second table also, but order is different. So here order what I did, I have just created with small int and then I went to int and then big int. Here I have small int, again I have big int, then again I went to integer. So what is the problem if you have this sort of data types followed by for the next column? So if you have this, since it is a fixed length data type, it will allocate a padding, extra space before any column. For example, before big int, it has some fixed data type, right? So it will allocate an extra space, waste space to it. So if you have an extra space allocated in the memory or disk, obviously your performance will also degrade. It has to read an extra space, right? So your read will be, we can observe read will be like a little bit slow. Okay, so we'll see one example how I have created two tables and I'm trying to insert the data. Okay, maybe I will try to insert with the same series generate data. I'm trying to insert like 25 lakhs of records in the first table followed by second tables. The same data I'm trying to insert. Yeah. Now if I see the count of my, I have 25 lakhs of the first table and I'm I'm trying to check the, okay. This is my second table and this is my first table. So both tables having the same records into it. Okay. Now what I will do, let me try to analyze these two tables. So what is the analyze? We are trying to gather the stats because optimizer is aware of how many records it has. Okay. I'm just trying to do analyze. Analyze is just similar like your stats gather in Oracle. Okay? I'm just gathering the stats of these particular tables so that optimizer is aware like this table have this many records and this table have this many records. Now we will go and see okay, what is the free space available in the each page. So this is my first table and similarly we can just check for the second table. So what is the difference between both? We have same table, same data type, same columns, only order I have changed. Then why it is showing different? Because I have same records in the table. If you see for the first table and the second table, you have observed difference. Okay, second table consumes some less space when compared with the first, right? Why it has consumed less space, we'll see now. Even we can able to go and read your page, okay? So the page, how it looks like. Let me go and read this. So we know this Infomax and I'm trying to read my, maybe let me do a limit. I don't want, okay, so this is for your first record. If you see the length of your record is 60, okay? This is for DVD pad table. Okay, similarly what I will do, I will also check for the other table, the second table, and we'll see how the row length looks like. Maybe I will just limit it to one record. And you see the length is 56. Here it is 60. So here 4 bytes is wasted. I mean, sorry, here 4 bytes is wasted. So here it allocated 60 and here we have the length is 56. So why we have difference? I have created same table, same column, same data, only the order is changed. Okay. So why? Because in the first table, since we have fixed length of your data types, before that data type, it will allocate an extra padding, an extra space. Okay. So because of that, the length is, okay, let me explain the paint to understand better. Let me share again. Okay. So this is my first table, table 1. Okay. I have, for example, integer 2 and integer 8, and I have integer 4, and I have int 8, okay, for example. This is for table 2. So for table 2, I've given int 8, int 8, int 4, okay, int 2. Okay, this is how I have declared. So just order I have changed. So in this case, what happens is, so for int 2, how it will allocate? So basically it is a 2. Finally, it will store in the bytes, right? I mean, in the bit, right? So for example, 0 and 1, 2, 3, 4, 5, 6, 7. Okay, it will still start from 0. I can just allocate. This is for int 2. So it allocates like 7 bits, right? And now for int 8, So basically here you are storing only two values for int 2. For example, you are storing 2 bits. The data is, for example, A, or maybe 0, 1, or maybe 12. So instead of confusing, I can just mention 12. So 12, for 12, it will allocate 2 bits, and this space is extra wasted, right? Okay, and since it is int 8, okay, here we don't have any waste. But here in int 4, since you are storing only 4, 1, 2, 3, 4, okay, remaining 4 is wasted. Okay, here you don't have waste. But if you rearrange the order here, so it won't waste any space, right? So here you have int 8, and 4, 2. So here it won't waste any space. This is your OS architecture itself. It will allocate space based on your data type, right? So that is the reason you are seeing the difference of your length. Okay, always whenever you are deploying any tables, okay, just order the table like this. Okay, see, we have seen here. Okay, so for this table, you don't see any padding. Okay, this is good in terms of performance than this table. Okay, so when you are creating any table, the order of your columns matters a lot in terms of performance. Okay, here you could see you have small int, integer. So you went from small to big, right? So you can just arrange this particular columns in such a way from small to big to get a better performance. But for this table, you could see the extra space is wasted, and your IOs will also obviously will impact, your performance will impact for read operations especially. Okay? And this is how we can think of before we do a deployment. Okay. Any questions here?
Suppose there is a DDL change to the table, right? A new column is getting added. Usually in Oracle, when a new column gets added, it will be added to the end of the last column, right?
Yes.
So for Postgres, how is it? If this order is so much important, then we need to.
Yeah, it is the same. Like Oracle, it will also append at the last. But the thing is, for new tables, whenever you are trying to create, it's always good that we can keep in mind about the order and we can deploy. So anyhow, later, whatever columns we add, we don't have any control. Again, you have to do a reorg kind of thing, so that at least while creating table, we have some control, right? So basically, whenever you are doing any deployments, they will create. Developers may not have idea regarding this kind of things. So whenever we are creating, we can suggest them to give this kind of order in terms of good performance. We don't waste your storage space as well as your, in terms of performance, it will be good. So later point of time, anyhow, we don't have any control, right? So that's how it works. Yeah.
Okay. Sure.
Yeah, so that's it we have for today. Probably we can discuss still more things tomorrow regarding, we can also try to run some queries, okay? And we'll see the difference between both the tables, okay? So today, actually, so we are running out of time, and probably tomorrow we'll discuss more about these things and toasting, okay? Which is one more interesting topic. So basically this padding is internal algorithm in Postgres. So based on the data type which you define, it will allocate the fixed length basically automatically in the memory area, and it will use the space. So the order, that's why the order is most important. Okay. Yeah, so that's it I have for today. Probably I will share the manual. You please try to practice and see how the page looks like and how the row page looks like. Okay.
One question, please.
Yeah.
Now, like you said, ordering of the ordering is important here, right? So, is there any documentation or any recommendations around the ordering? If you have, let's say, in all 10 data types, so what should be your preferred ordering?
Yeah, preferred ordering is from small to big data types you can go. For example, I have shown, right? So yeah, maybe we will share because first we have to understand each data type, how the length if you take int, how much length it has. If you take float, how much length, how many bytes it will allocate. So that first we need to understand, and then it's easy. the only thing is we need to understand the length of the data type based on your data type which you define. It's a float, begin. So Postgres have like a bunch of data types supported, more than Oracle, I can say. Okay, so that we need to understand. So that particular link I will share in the lab manual where we can refer the length of each and every data type. Okay, and even so we'll provide the PostgreSQL.org documentation regarding the padding, how it works. Okay.
Yeah, just adding to like Suresh, that one. Okay, so the ordering. Okay, so this is like we are defining or like we are suggesting from the database point of view. But again, so in like in real-time systems, that is depending on the business logic, and there is a coordination between database team and application team to like define these things. Okay, so yeah, as I said, we will provide some reference documents. Okay, so then you can refer those things. Okay, and it is completely depending on the coordination. If you refer those documents also, you will get like what are the things required from database. But again, so this is a coordination between the like application teams and database teams to define your business logic. Okay, yeah.
All right, understood.
We can close the class for today. If no other doubts, we can close the class.
Yeah, thank you.